Welcome to Mohan classes. In this video we are going to talk about circles. This is for 9th standard part 1 video. Let us start. So here we are going to talk about the chord, how the chord will behave in a circle. So the perpendicular from the center of a circle to a chord bisects the chord. Here O is the center and AB is the chord. Okay, now we are going to draw a perpendicular from O to the chord AB. So it meet the chord AB at M. Now what we have to prove, this perpendicular will bisect the chord, that we have to prove it. Let us see. So here in triangle OAM and OBM, we have to prove these two triangles are congruent. Once if you are proving the triangles are congruent, then we can prove our chord, perpendicular bisect the chord. So in triangle OAM and triangle OBM, OA is equal to OB. Why? Radii radius of the circle. OA is the radius as well as OB is the radius. Therefore OA is equal to OB. And angle OMA is equal to angle OMB is equal to 90 degree, because OM is the perpendicular. Therefore this angle will be 90 degree. Similarly this angle will be 90 degree. Okay, then OM is common, right? Therefore the triangle OAM congruent with triangle OBM. These two triangles are congruent. If these two triangles are congruent, then we can say that AM is equal to BM by CPCT. What is CPCT? Corresponding parts of congruent triangles. This triangle, how you are saying OAM, triangle OAM is congruent to triangle OBM. We are saying by here what? Yes, A by SSA rule. This side is equal, this side is equal, this angle is equal. Therefore we are saying SSA rule. We are saying these two triangles are congruent. So these two triangles are congruent, then AM is equal to BM. So if AM is equal to BM means OM, the perpendicular, bisects the chord AB. Hence the proof. Clear? So here what we did, we have taken OAM and OBM, these two triangles. OA is equal to OB and OM is common. Angle OMA and OMB is equal because OM is the perpendicular. Therefore these two triangles are congruent. AM is equal to BM. If AM is equal to BM means this perpendicular bisects the chord. Okay, let us go to the next. Here the line drawn through the center of a circle to bisect a chord perpendicular to the chord. Here we have to, it is a converse of the previous one. So here what is the converse? There what we studied in the previous one, here we studied if it is a perpendicular, then it will bisect the chord AB, right? So here what we have to prove, the line drawn through the center of a circle bisect the chord. So the line drawn from center of the circle bisecting the chord. So what is given here? Given is AM is equal to given AM is equal to BM. It is given. What we have to prove that? To prove that, we have to prove angle OMA is equal to angle OMB is equal to 90 degree. Then only we can say OM is the perpendicular. OM is the line drawn from the center to the chord, right? So now what is the proof? The same, we have to take the triangle in triangle OAM and triangle OBM. OA is equal to OB, radii, right? And then OM is common. Then we can say that AM is equal to BM. It is given. So it satisfies yes, 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 triple S. Therefore, triangle OAM congruent to triangle OBM. Okay, if these two triangles are congruent, we can say the angle OMA is equal to angle OMB. Okay, it is M. OMB. OMA is equal to OMB. What we are saying? This angle is equal to this angle by CPCT. It is by CPCT, this is by triple S rule. Okay. So now OMA is equal to OMB. So what is this OM? OM is, this is a linear pair, right? So what I am going to say is, here we will write angle OMA plus angle OMB is equal to 180 degree because it is a linear pair. So OMA is equal to OMB. So I am going to write twice of angle OMA is equal to 180 degree. Therefore, angle OMA is equal to 90 degree because 180 divided by 2 you will get 90 degree. Therefore, OMA is equal to 90 means this is the OM is the perpendicular to the chord AB. Therefore, OM is the perpendicular to the chord AB. Hence the proof. Clear? So what we did, we have proved these two triangles are congruent. So these two angles are equal. It is a linear pair. So these two angles are equal, therefore 2 OMA is equal to 180 degree, OMA is equal to 90 degree. Okay? Move to the next. Here the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So that means this angle POQ is equal to twice of PAQ. So that we have to prove that. What we have to prove that? We have to prove angle POQ, angle POQ to prove, let us take here, to prove that angle POQ is equal to twice of angle PAQ. This is the thing what we have to prove that. So let us join OA and extend to B. Okay. So join OA and extend to B. Okay. Now angle POB. What is angle POB? Exterior angle of a triangle. Angle POB, exterior angle of a triangle POA. This angle plus this angle, right? So OPA plus angle PAO. So exterior angle is sum of the opposite angles, right? So OPA is equal to PAO. Here OP and OA are the radius. So what I am saying is this angle is equal to this angle. Why? Equal sides. The angles opposite to the angles opposite to the equal sides, because it is a radius, it is a radius. Okay. So here what I am going to say, OPA, angle OPA is equal to angle PAO. Why? Angles opposite to equal sides. Similarly, we can say angle BOQ. Angle BOQ, sum of these two angles, right? Angle OQA plus angle OAQ. Here also it is a radius, it is a radius. So this angle is going to equal to this angle, because angles opposite to the equal sides. So here also I am going to say angle OQA is equal to angle OAQ. Why? Same. Angles opposite to equal sides. Okay. Now what is angle POB plus BOQ? Now we can add these two. Okay. So angle POB plus angle QOB. What you will get? This OPA is equal to PAO. Both are same, right? I am going to write PAO. Let us take 2 PAO. 2 PAO plus this OQA is equal to OAQ, right? So I am going to write 2 OAQ. Understand what I am saying? So these two angles are equal, so that I am writing, instead of OPA plus PAO, I am writing 2 PAO, and for this I am going to write 2 OAQ. Now what is POB and QOB? That is angle POQ. Angle POQ is equal to twice of angle POO plus OAQ, right? What is PAO plus OAQ? PAO plus OAQ is equal to angle PAQ. That is equal to twice of angle PAQ. Hence the proof. Understand? So by using this theorem, you may get a question like this. It is the center. Like this. Okay. So they would have given this angle as 120. So what is x? So what is x? P, Q, A. What is angle PAQ? This angle PAQ will be, it is 120, right? Angle PAQ is equal to what? Half of this 120. That is equal to 60 degree. So this angle is 60 degree. If it is 60 degree, this angle will be 120. Similarly, you can ask another question like this. This angle is 45, let us take it as 55 degree. Okay, this angle is 55 degree. So what is this angle? It is x. So this x is equal to what? 110 degree. Understand? So like this you may get a questions in your exams. So let us move to the next. So here, what is the question? If two intersecting chords of a circle make equal angles with the diameter, passing through their point of intersection, prove that the chords are equal. So we have to prove the chord AB is equal to chord CD. Okay, AB is equal to chord CD. This is the thing what we have to prove. How we will prove that? So now O is the center of the circle. Draw a perpendicular OL to AB and OM to CD. First we have to draw OL perpendicular to AB and OM perpendicular to CD. Okay. Now, what is given? Angle AEQ is equal to angle DEQ. It is given. Equal angles with the diameter. PQ is the diameter of the circle. So, this angle AEQ is equal to angle DEQ. It is given. Okay. So what is LOE? Now angle LOE. What is this angle? We have to find out. What is angle LOE? Angle LOE is equal to 180 degree minus, because it is a triangle. LEO is the triangle. Sum of the three angles are 180 degrees. So I am going to minus these two angles from 180. So what I have to minus? 90. So this angle is 90 degree because it is a perpendicular. These two angles are 90 degree. 90 plus angle LEO plus angle LEO. 90 plus LEO. So that means 180 minus 90, you will get 90 minus angle LEO. So 90 minus LEO. This LEO we can write it as LEQ or LEO. LEO itself correct. So now what is LEO? LEO is equal to DEQ, right? This angle, because it is given. So what I am going to say, LEO is equal to MEO. Correct? So I am going to write it as 90 minus angle MEO. So 90 minus angle MEO, what you will get? This is equal to MOE, right? Angle MOE, this angle. Understand? 90 minus angle, this angle is going to get, because this is 90 degree, this 90 minus this angle is equal to this angle. Correct? Same like that. So here what we have proved, angle LOE is equal to angle MOE we have proved. Now in triangle OEL and OEM, in triangle OEL and triangle OEM, these two triangle LEO is equal to angle MUO. LEO it is given. Why? AEQ is equal to DEQ. So instead of A, I am taking it from LEO and MUO. Then after that, already we have proved angle LOE is equal to angle MOE. We have proved. And then what else? EO is common, right? This angle is, this side EO is common. So we can say these two triangles are congruent, right? Therefore, triangle, what is this? OEL congruent to triangle OEM by AAS by AAS rule. So if these two triangles are congruent, then we can prove that OL is equal to OM. OL is equal to OM. If OL is equal to OM, you see, it is the axiom that any chord from the center is equal, then the two chords will be in equal length. OL is equal to OM, therefore AB is equal to CD. We have to write the reason why you are saying AB is equal to CD. Equidistance chords are equidistance from the center. Therefore, equidistance from the center. Therefore, the chords are equal. It is the reason you have to write. Okay, very, very important. So equidistance from the center of the chords will be equal. Equal chords will be equidistance from the center. Okay, understand? Now, last one here. The sum of either pair of opposite angles of a cyclic quadrilateral is 90. So here we are going to talk about a cyclic quadrilateral. What is cyclic quadrilateral? A quadrilateral lying inside the circle. Okay, it is the quadrilateral. A, B, C, D is the quadrilateral lying inside the circle. So the sum of the opposite angles of a quadrilateral is equal to 180 degree. That is angle BAD plus angle BCD is equal to 180 degree means the quadrilateral is called a cyclic. Then ABCD is a cyclic quadrilateral. Similarly, these two angles also opposite. Sum of the opposite angles of a quadrilateral is equal means then we can say it is a, similarly we can say angle ABC plus angle ADC is equal to 180 degree means then we can say ABCD is a cyclic quadrilateral. Okay, so this is very important. The cyclic quadrilateral means sum of the opposite angles of a quadrilateral should be 180 degree. Then we can say the quadrilateral is a cyclic quadrilateral. So some rules here I am going to tell you. You see equal chords. AB is a chord and CD is the chord. Here AB is equal to CD. These two chords are equal. Let us say these two chords are equal. If AB is equal to CD, then AB and CD will be equidistant distance from the center. So that means this OM is equal to ON. This is the perpendicular, this is the line from the O is the center, OM and ON. Then only this equidistance. It is suppose vice versa. If AB and CD are equidistant from the center, we can say AB is equal to CD. If OM is equal to ON, then what we can say? Then AB is equal to CD. It is the converse. Understand? That's it. Thanks for watching. If you like this video, kindly share it to your friends and don't forget to give your likes. Bye.